The rotor induced voltage, let's discuss about the rotor induced voltage. The rotor induced voltage at standstill, that is standstill, that means when n is equal to 0, that means rotor at a standstill condition. So the rotor induced voltage at a standstill per phase is given by E2 divided by E1 is equal to N2 divided by N1, where this N2 be the number of rotor turn per phase, N1 be the number of stator turn per phase, E1 be the stator voltage per phase for stator is for the rotor turns, stator turns per phase. Okay, so here in this equation is similar to the transformer, where secondary voltage is proportional to the turns ratio of the winding. Hence the rotor induced EMF at standstill is proportional to the turns ratio. Okay, then the induction motor is therefore due to this E2 is equal to N2 divided by N1 into E1. Due to this ratio, your three-phase induction motor is called as a rotating transformer. Rotor induced voltage under running condition. Okay, so when the rotor accelerates, the relative velocity between the rotating magnetic field and the rotor decreases, as we know that. So this will reduce the rotor induced voltage in the rotor winding. Hence the rotor induced voltage per phase under running condition is given by E2R. Let's say E2R be the rotor induced voltage under running condition, but as we know that this E2R, that is a rotor induced voltage under running condition, is directly proportional to the relative speed between the stator and the rotor. Okay, that is relative velocity, and as we know that the secondary voltage is directly proportional to the ns. Okay, that is synchronous speed. If we took the resultant of this secondary induced voltage under running condition divided by rotor induced voltage under standstill condition, then we got ns minus n divided by ns, which is nothing but the sleep. Okay, hence the rotor induced EMF under running condition divided by rotor induced EMF is equal to S. Hence we can conclude that the rotor induced voltage at a running condition is equal to sleep times the rotor induced voltage at a standstill condition. This is the formula for the rotor induced voltage under the running condition. Okay, as we from this equation, as we know that when sleep becomes equal to 0, then the secondary induced voltage E2R becomes equal to the induced voltage at a standstill. Okay, thus the rotor induced voltage fluctuates between, when S becomes equal to 0, obviously the secondary induced voltage becomes 0. That means this secondary induced voltage under running condition, that is E2R, fluctuates between 0 to E2R. Okay.